What is up, y'all? Mr. A here with another A-Space math video. Today we're going to talk about the unit circle. And if you're still trying to memorize all the values of the unit circle, remember, it's cool to memorize, but it's even more cool to understand. So today I'm going to show you where all these values come from. If you haven't checked out the special triangles video, check that out first, and then hop over to this. Let's get started. So here we have our unit circle, given its name because of the fact that the radius is 1. That's what makes it a unit circle. We're going to talk about what the values of sine and cosine are on the outskirts of this circle. And let's start off by doing a very simple move. We're going to split this up into fourths. And we're going to focus on that first quadrant, because really that first quadrant is the only one you really need to know. And all the values for the other quadrants are given to you by symmetry. Finding the value of cosine and sine of theta for this specific angle pi over 4 comes down to understanding what the values of our special right triangles are. Pi over 4 is the same as 45 degrees. And if you're not sure how that came about, look at our video on how to convert degrees to radians and vice versa. This angle here is 45 degrees, which means that this angle over here must also be 45 degrees, which means that we have an isosceles triangle, which is one of our special right triangles. We have two angles that are 45 degrees and a right angle. We know that these two sides must be equal to root 2 over 2 and root 2 over 2. In this situation, where our theta is 45 degrees, our two sides are equal length, which makes sense because both of our angles are of equal measure. So our cosine is root 2 over 2, and our sine is root 2 over 2, which remember are the x and the y coordinates for this point here on the outside of our unit circle. So now we know that the value of cosine at pi over 4 or 45 degrees is root 2 over 2. And the value of sine at that same angle is also root 2 over 2. Remember, if you're not sure where this root 2 over 2 came from, check out our video on special right triangles. All right, let's move it on over and find the values of sine and cosine for the next two angles that we have left over on this first quadrant. So that's the first angle that we'll find the values of cosine and sine to. And the other angle will be very similar, and you'll see why in just a second. So sine is this vertical distance here, our y value. Cosine is this horizontal distance, our x value. Now we're going to take this angle and convert it to degrees to use our special right triangles rules. Pi over 6 radians is equal to 30 degrees. And remember, if you're not sure where that came from, check out our video on converting from degrees to radians. For now, we see that we have a 30-degree angle here, which means that this angle up here must be 60 degrees. And this angle is clearly 90 degrees. So we have a 30, 60, 90 special right triangle. And we know by the properties of special right triangles that the side opposite to the 30-degree angle is 1/2, which means that our sine is 1/2, and the side opposite to the 60-degree angle is root 3 over 2, which means that our cosine is root 3 over 2. And there we have the value of cosine and sine for the 30-degree angle, or the pi over 6 angle. And we're going to follow the same procedure. We're looking for the coordinates of that point there, which are cosine of theta, which in this case again is pi over 3, and sine of theta. We know that the sine is this vertical distance, and we know that the cosine is this horizontal distance. If we convert this pi over 3 to degrees, we know that it is equal to 60 degrees, which means that this angle up here must be 30 degrees, since this angle here is 90. But this should look familiar at this point. We have another special right triangle, but it's really the same one as the one we had before. We have a 30, 60, 90 special right triangle. And again, our side opposite to the 30-degree angle is 1/2, which means that our cosine of theta is 1/2 when theta is 60 degrees, or pi over 3. And our side opposite to the 60-degree angle is √3 over 2, which means that our sine of 60 degrees, or our sine of pi over 3, is √3 over 2. And now we've completed all the angles for this quadrant. Let's go ahead and generalize for the rest of the unit circle. So from our previous work, we have this first quadrant all filled out. We have the values of cosine and sine for every single one of these angles. Pi over 6, pi over 4, pi over 3, of course 0, and pi over 2. Now let me show you that this is really all you need to find the rest of the values of cosine and sine. I want to bring your attention to a pattern that's going on here. Notice that our cosine is starting off at 1, and then it is slowly decreasing, and our sine is doing the opposite, starting off at 0 and slowly increasing, which makes sense, right? Because first our x-coordinate is large, it gets smaller, smaller, smaller. Our x-coordinate is getting shorter and shorter and shorter and shorter as we go around the unit circle. And our y-coordinate is getting longer and longer and longer and longer as we go around the unit circle. Cosine starts at 1, but we could also write that, to make it convenient, as the root of 4 over 2. Because the root of 4 is 2, divided by 2 would give us 1. And the reason I wrote that in that weird way is because, if you notice, we have a pattern where we have a root of something, and every angle, that root just goes down. So we have √4 over 2, then √3 over 2, then √2 over 2, then √1 over 2, which is just 1 over 2, and then √0 over 2, which is just 0. And for our sine, the opposite is happening. We're starting at √0 over 2, which is just 0 over 2, or 0. And then that number in that square root is going up as we go around the unit circle for our first quadrant. So it goes √1 over 2, which is just 1 over 2, √2 over 2, √3 over 2, √4 over 2, which we showed previously, is just 1. That's another way to understand the pattern that's going on here. Be sure to like and subscribe for more.